Polar coordinates. We know that the rectangular coordinate system lists the points in the plane. The first coordinate is x and the second coordinate is y. Notice that to get to the point x, y, we start from the origin, go to the right x units, and then go up y units. The horizontal distance from the point x, y to the y-axis is the distance x, and the vertical distance from the point x, y to the x-axis is the distance y. When the distance from the origin or the angle plays a role, such as the gravitational force exerted on a planet by the sun depends on the distance r, or when a satellite orbits the Earth, then another coordinate system is more natural, called the polar coordinates. In the rectangular or the Cartesian coordinate system, the point is labeled x, y. In the polar coordinate system, the point is labeled r, theta, where r is the distance from the point to the origins or the radius, and theta is the angle formed by the ray from the origin to the point and the positive horizontal axis. In polar coordinate system, the origin is called the pole. The distance from any point P to the pole is called the radius. So the radius is the distance OP. The angle that this ray forms with the positive horizontal axis, the positive horizontal axis is called the polar axis, and the angle form is theta. R is called the radial coordinate, and theta is called the angular coordinate. The grid lines or the help lines in the Cartesian or the rectangular coordinate system consist of the horizontals and the vertical lines. In polar coordinate, the grid line or the help lines are circle of radius 1, 2, 3, 4, 5, and the rays starting from the origin indicating the angle. Pi over 2, pi over 4, pi, 3 pi over 2, 2 pi, and so on. These are the standard angles labeled in the counterclockwise orientation. The standard labels are usually 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, and so on. Observe that in the rectangular coordinate system, the representation of a point is unique. Given any point, we can obtain the x and the y coordinate of that point, and there's only one way to represent that point with an ordered pair, and vice versa. If we were given an ordered pair x, y, we can only locate one point for that ordered pair. In the polar coordinate system, there are many representations for any given point. That is because to locate the point P, for example, we can use the angle theta, or we can use theta plus 2 pi, or we can start from the positive horizontal axis and travel clockwise, which will give us a negative angle. In addition, we're allowed to use the negative radial coordinate. Negative r is defined to be the same distance from the origin to the point, but in the opposite direction. For example, any point in the first quadrant has a negative r in the third quadrant. Any point in the fourth quadrant has a negative r in the second quadrant, and so on. To plot a point in the polar coordinate system with the radial coordinate r and the angular coordinate theta, we start with the positive horizontal axis and sweep an angle either positive theta by going counterclockwise or negative theta by going clockwise. Once we obtain the desired angle, we can start from the origin and go out the distance of r. For example, to plot the point P 2, pi over 4, we will start at the positive horizontal axis, sweep an angle pi over 4, stop at this ray pi over 4. We then start from the origin and go out 2 units. To plot the point -2, pi over 4, we will start from the positive horizontal axis, go to the ray pi over 4, count 2 units, but this time we want the negative radial coordinates, so we would need to go to the opposite side. Thus, -2, pi over 4 end up in the third quadrant, even though the angle is pi over 4.